All right, so this lecture will be in two parts. Here was a connection problem with my work computer. I was online, but EKU bumped me off, so that's okay. We'll just continue on. We're on question 11. We'll just, in case you missed it, here it is. And we'll go on to question 12, and then we're going to take a break. Okay, so let's go to question 12. We're going to take a much needed break. So question 12 says, draw the major thermodynamic and kinetic products of the reaction. They show us this. We're going to have a 1,4 and a 1,2 addition. So the kinetic product is going to be the 1,2 addition. We're going to have this. Then we're going to draw the 1,4. So this is kinetic. The thermal product will be this right here. So I'll leave this up here. We'll take a break and then we'll come back. All right, hello everyone. Let's continue on. We'll go on to question 13 now. Question 13 says, provide the major product of the reaction sequence. If cis-trans isomers are possible, draw only the major isomer. If enantiomers are possible, do not specify configuration. So they give us bromine and 2 equivalents of sodium cyanide. Let's see. So with this right here, remember this is Br2 in heat, not just HBr. So what we're going to get with this is this product right here. Then we're going to have sodium cyanide, which we're going to have an SN2 reaction here. This will be gone. And we're going to do the same thing. It says 2 equivalents, so we'll do the same thing on the opposite side too. So finally, what we're going to be left with is what they want. They want you to draw this. So you'll be drawing this for the final answer. So it's 13. I think that was 13, yeah. We can even put 14 on here because 14 is only a one word answer. It says classify the reaction as ionic, radical, or pericyclic. Well, it's not an ionic reaction. It's not a radical reaction. We don't see the movement of one electron. So the only option left is pericyclic. Then we can put 15 on this slide too. 15 says compound A is a diene. B, that's going to be your dienophile. And C is your Diels-Alder adduct. So 14, okay, so I got this a little mixed up, but this will be 16. 15 is also pericyclic. I must have skipped over that one, but we have two pericyclic ones. So 14 and 15 are pericyclic. 16 then is your diene, dienophile, and Diels-Alder adduct. So 17, moving on, this is just gonna be a Diels-Alder product with, or Diels-Alder adduct with a diene, a dienophile. You have this right here. This is gonna come up. You have this compound. So you're gonna draw this like this. Let me start over. Basically, you have this and you have some other stuff on here as well. This is going to come here. This is going to come here, and that's going to force this point up. So then what you're going to have is a 6-membered ring with a bridging carbon. Then you're going to have the other stuff. I'm just going to call this stuff R, and then I'll redraw it in for the answer. And we have that right there. That's 17. 18, they want the, we can put 18 on the same thing, on the same slide. They want the retrosynthesis. It's almost, it looks exactly like this. So we have a reactant A. And a reactant B. And that's all I want. Then you can imagine how, you know, I'm going to have to erase this, but this will come in here, this will bump, and you'll get your ring structure. But I don't want to do that because that's not what the answer requires. So you have 17 and 18 done. All right, so let's go to 19. They just want us to draw the arrows for the dienophile. Here's our nice electron withdrawing groups. Oh, it's drawing too much. Have an arrow here, have an arrow here, and have an arrow here. So we have 3 arrows. That's 19. All right, so let's go to 20. When he says for the deals Alder reaction, the product skeletal structure and configuration at the bridgehead carbon. So they give us this. And we're going to have some type of reaction. We have to draw the final product. So this final product is going to be kind of complicated for what they want. So there you go. So these 2 carbons right here are going to come up, and you're seeing this right here. So I'll go ahead and let you draw that. I know it might take a while, so just take your time. Okay, so hopefully everyone was able to do that. We'll do one more and we'll end it for the day. We'll go on to 21. We'll finish this tomorrow. Then we'll go on to chapter 17. So I'll get that loaded today. No, I already have chapter 17 loaded. I just have to come up with the homework questions today. So this is question 21. 21, it says an electrocyclic reaction is an intramolecular reaction. Draw the curved arrows. So that's what they want. So we'll start here. We come over here. We have it right here. So we broke that pi bond and we formed a sigma bond. Is that it? Okay, so then modify the structure to give the thermal products, and then we're going to give the photochemical products. So we'll give the thermal product here. A little close. Oh, as I said, I'm getting too close to the edge. It doesn't want me to draw that close to the edge. We got the thermal, and then we'll give the photochemical product. So we gave the photochemical product. So that's it. So for the thermal product, we're going to have a disrotatory. And disrotatory means, you know, we're going to be rotating this way. We're going to rotate this way. That's why they're both pointing up. And for the photochemical, it would be conrotatory. So we're going to be moving in the same direction. Oh. That's all we have for today. So you can see how, you know, we're moving this hydrogen up and this one's going down. So we have one up and one down. That's it. So I will see everyone tomorrow. Have a great day. And just remember to keep up with your homework due dates.